Alright, Fernando assembles computers on a part-time basis. He earns $100 a week plus $65 per computer part that he can assemble in a week. Which equation or inequality can be used to determine how many computers he has to assemble in order to make at least $1,000 in a week? Few keywords I see here are equation, inequality, and at least. And the word at least tells me that this is going to be an equation, an inequality, not an equation. Let me repeat. The fact that it says at least tells me it's going to be an inequality, not an equation. If it said at most, I would know it's an inequality and not an equation. Equation means equals. If this problem said how many computers does he have to assemble in order to equal $1,000 or to make $1,000 even, whatever, then it would be an equation. And the way I interpret these two keywords, or this keyword, at least is kind of tricky. It means it could be more than or equal to whatever you're talking about. So for example, if I had at least $5 in my pocket, at least, that means that's the very least I have. So I could have 6, I could have 7, and I also could have 5 because I've got at least 5. I could have all the way up to however much money there is in the world. Now if I said at most $20, that means that's the very most I have. So the most I could have is 20. I could not have 21. I could have $19. I could have $10. I could have a penny. Because the very most I would have is 20. So it's kind of a tricky problem because when you think at least, you're thinking less than. That's not true. When you see at most, you think more than. That's not true. It's a play on words. Now if I said more than, obviously that's easy to interpret. But at least and at most are two very tricky phrases that you really need to think about in order to solve a problem. Okay, so keeping all that in mind, let's go through these answer choices to determine which one it is. Let's look at J. $100 plus $65 per computer, represented by X, is greater than or equal to $1,000. The way I interpret this is this entire side right here represents earnings. Okay? And then the rest of it I would rewrite. That means his earnings are greater than or equal to $1,000. Isn't that what we want? If he wants to make at least $1,000, his earnings need to be greater than or equal to $1,000. And the way I interpret this symbol, the way I was taught to read this was pretend it's like an alligator's mouth. Okay, I'll even draw some teeth in there for you. Alright, the alligator always wants to eat the bigger thing. He wants to eat the bigger side. So right now this earnings is bigger than $1,000. But you can't forget to interpret this bar beneath it because that means it could equal 1,000. So his earnings represented by 100 plus 65x is greater than or equal to 1,000. It's not H because that's an equation. That's not what we wanted. It's not G, that's an equation. Could have been F, but that's 100 minus 65x. He'd be getting robbed. So it's answer choice J. Last thing on this problem, know the difference between these phrases right here. That says X is greater than 5. This says X is greater than or equal to 5. And it's all the differences in this little bar beneath it. The way you would shade that, the first one, the way you would shade this one right here would look like this. If there's 5, this is a number line, you would just put a circle around it and circle to the and shade to the right. If it were the second one, this one, you would graph it like this. You would put a dot on it. And the way I remember being taught that is if it takes more work to write the line, you take more work and fill in the dot.